Whatever external thoughts you apply, he is not accept. Here I will just compare with the equations of motion. Then what is angular velocity? The axis of rotation or the center of rotation. The shape and size of the body will not change. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. A new session, new constructive thoughts, steps to demolish the destructive ones, a new folds of vagaries. In my present session, I will be starting a very new chapter, what is called system of particles. Dear students, this chapter is also called as rigid body dynamics. Dynamics of a rigid body, which means we first try to understand what actually is a rigid body. And when I say dynamics of a rigid body, it is simply a comparison, simply an analogous of all concepts you study with respect to a body in linear motion compared with a body which is rotating. Al velocity ant karitira. Here you study angular velocity. There you study acceleration. Here you study angular acceleration. Displacement, angular displacement. In Newton's laws, you studied inertia of a body. Here you study moment of inertia. Linear motion, you studied something called as force. Rotational motion, you will study something called as torque. So the entire assessment here is to compare the concepts of mechanics with respect to a body which is moving along a straight line and a body which is exhibiting rotatory motion. So today we first make an attempt to understand what actually is a rigid body. The very word rigid means something which does not want to accept changes. He is a very rigid fellow. Whatever motivation you bring, whatever external thoughts you apply, he is not accept the changes. Then what is a rigid body? We say a rigid body is one whose shape and size remains unchanged. Shape as well as size remains unchanged under the action of external forces, and these external forces are also called deforming forces. It is very, very difficult to deform such a body even under the influence of an external force. The body will not get deformed. The shape and size of the body will not change. No deformation happens even when I apply an external force, and such a body is called a rigid body. It is rigid to accept any change. Whatever may be the external force applied, whatever may be the magnitude of the deforming force, the body will not change its shape and size, and such a body is called as a rigid body. Now, a rigid body can have translatory or rotatory motion, but no oscillations. The characteristic feature of a rigid body is it always rotates, and the distance between any two particles in such a rigid body always remains the same. Andre, suppose I have a rigid body rotating about an axis. These are the particles constituting the rigid body, the particles which will build the rigid body. Remember, the distance between two particles of this system always remains same. That is why it is rigid. That is why it is not susceptible to changes. So, what is a rigid body, students? Whose shape and size cannot be changed even when there are external forces, even when there are deforming forces. Such a body cannot be deformed. It can either have translatory or rotatory motion, and the basic cause for this rigidity is the distance between any two particles of the rigid body remains same. Now we learn a few definitions as concerned to a rigid body. The first definition I learn is angular displacement. Linear displacement, change in position with respect to time in a specified direction, then what is angular displacement? I consider a rigid body rotating about a fixed axis passing through a point O. Let P be a particle at a distance r from O. So, P is a particle which is at a distance r from O. O is called the axis of rotation or the center of rotation. The straight line joining the axis of rotation with the particle is called radius vector. So please to understand, the straight line which joins the center, the so-called axis of rotation with the particle. So OP is R, which is called as radius vector. Now in a certain interval of time, what I call as T, the particle moves from the point P to the point Q. Now it is getting displaced from the point P to the point Q by making an angle theta with the axis, and this is what is called angular displacement. The angle made by the radius vector with the axis at a given interval of time is what we call angular displacement, and it is always measured in radians. Notice? So beautiful. The straight line which joins the center, the so-called axis of rotation with the particle is called radius vector, and the angle described by the particle, or you can say radius vector with the axis in a certain interval of time, is called angular displacement. The particle is getting displaced by defining some angle, and this angular displacement is measured in radians. The next one is called angular velocity. How did you define linear velocity? Rate of change of linear displacement. So generally, velocity is displacement divided by time. Then what is angular velocity? Rate of change of angular displacement. Notice, that is what I told. Comparison between linear motion and rotatory motion. Linear velocity is linear displacement divided by time. Rate of change of linear displacement. Angular velocity is rate of change of angular displacement, and it is called angular velocity. Therefore, we say omega, which is angular velocity, is angular displacement by time, or omega is angular displacement is theta divided by t, and it is measured in radian per second. So, angular velocity omega andre, it is the rate of change of angular displacement. So, omega is angular displacement divided by time, theta divided by t, and it is measured in radians per second. Angular acceleration. How do you define linear acceleration? Rate of change of velocity, or acceleration is velocity divided by time. So, angular acceleration, it has to be rate of change of angular velocity, and it is denoted by alpha. Rate of change of angular velocity divided by time. So, alpha, angular acceleration, is defined as angular velocity divided by time. Alpha is omega by t, and it is measured in radians per second square. So, we now learnt what is angular displacement, angular velocity, angular acceleration. Based on that, we will frame the equations for rotational motion. Very important. This is asked as a 3 marks question. The equations for rotational motion. Consider a rigid body moving with initial angular velocity omega 1. A rigid body which moves with initial angular velocity omega 1. Linear motion alli initial velocity ant karitidvalla, here it is initial angular velocity omega 1, rotating with a constant angular acceleration alpha. So, omega 1 is the initial angular velocity and alpha is the angular acceleration. Omega 2 be the final angular velocity in a time t. Then the equations for rotational motion are, here I will just compare with the equations of motion in a straight line. First equation of motion, V equals u plus at. This is for linear motion. For rotational motion, what is final angular velocity? Omega 2. Initial angular velocity, omega 1. Acceleration alpha. Time in any motion is the same. Simply compare linear motion with rotatory motion. Second equation of motion, S equals ut plus half at square. This is for linear motion. Comparing for rotational motion, displacement is theta. Initial velocity omega 1t plus half alpha t square. See how beautifully we are constructing equations for rotational motion. And v square equals u square plus 2as. Omega 2 square is omega 1 square plus 2 alpha theta. Third equation of motion. So just by comparison, we are arriving at the equations of motion for rotational motion. So dear students, in today's session, we have understood the basic definition of a rigid body. What is angular displacement, angular velocity, angular acceleration for a rigid body, and the three equations for rotational motion in comparison to linear motion. In the next session, I come up with a beautiful topic called moment of inertia. Until then, have a nice time. Thank you.